For this example, we are given the scenario where a cup of coffee is heated to 180 Fahrenheit and placed in a room that maintains a temperature of 65 degrees Fahrenheit. The temperature of the coffee after T minutes is given by the T function, 65 plus 115 e to the negative 0.042 T. So it wants us to find the temperature to the nearest degree of the coffee 10 minutes after it's placed in the room, and then determine to the nearest tenth of a minute the temperature of the coffee when the temperature of the coffee will reach 100 Fahrenheit. So no unit conversions to worry about here. And we will start again using our graphing calculator. So we're back to the graphing calculator, and I've pre-entered the function into the calculator, 65 plus 115e to the power negative 0.042 t. And the first question said, find the temperature to the nearest degree of the coffee 10 minutes after it's placed in the room. So no units to worry about here. My table settings are already set. So I'm going to go to my table. And again, I need to delete any values that I've previously entered because I do not need those. I need the ones or the one that this question is asking for, and that is 10 minutes. And hit enter. So that tells me that 10 minutes after the cup of coffee is placed in the room and it's at rest, is the temperature is going to have been reduced to 140 degrees or 141 degrees. So now the second part is saying determine when to the nearest tenth of a minute the temperature of the coffee will reach 100. Well, that we're given the y value. So now we're given t, or sorry, we're given capital T as opposed to the time, we're given the temperature. We cannot use this table of values to solve this portion. So we need to go to our y equals and graph the line y equals 100. And then go to our graph. Again, before going to the graph, I've already done this. I've already manipulated the window settings. I've set the window to 1 hour, right? To 1 hour. And the scale is 10 on the x-axis. I went as high as 200 Fahrenheit, even though the maximum was 180. I went as high as 200 so I could see the entire function. And then I go to graph. So there is my graph. So you'll notice already, remember my y scale was going up by 20, up here 180, 180 being the y-intercept in this case. So the temperature initially is 180 Fahrenheit. And you see at 100 that it appears to be somewhere around, what was my scale again? Was it 5 or 10? My scale was 10. So we're looking at 10, 20, so less than 30 minutes, it's going to be at 100 Fahrenheit, so less than half an hour. Let's find that intersection point so we know exactly how long. Second, calculate, and we want the intersection point. Again, select your first curve, hit enter. Select your second curve, hit enter, and then hit enter one more time. And it tells us that after about 28 minutes, it has reached 100 Fahrenheit. So let's go back to our worksheet and record our final results. So back to our worksheet. We are able to summarize these two parts of question 3 as follows. When asked what the temperature of the coffee will be to the nearest degree after 10 minutes after it's placed in the room, we can conclude that it will reach 141 degrees Fahrenheit. Now, when will it reach 100 Fahrenheit? So how long will it take for it to reach 100 Fahrenheit? In this case, the coffee will reach 100 Fahrenheit after 28.3 minutes.